Scientists unite to resolve a vengi in this
Math
fight
scientist.
together.
Hello guys, welcome to the first tutorial on the PIC Microcontroller. We're going to be doing a tutorial series on the PIC 16F877A microcontroller. Okay, so let's begin. So what we're going to do is we're going to do a blinking light tutorial this video. And what we do firstly, we're going to create a new project. We're going to give the project a name, blinking. I've already created a project similar to this. I'm naming it blinking, saving it to documents, then selecting the microcontroller as PIC F877A. Okay, say overwrite. So as you can see, we're using the microC ID. These other IDs which are available. This is my use case, right? But there are other possible alternatives like MPLab. Okay, so firstly, we're going to say trace A equal to 0. So what are we doing here? If we go and look at in Proteus, if we look at the structure of the PIC 16F8, there's 5 ports. There's an A port, port, and E port. Now with these ports, we're going to try and manipulate this single port, turning it on and off as we go along. Okay. So firstly, this A is equal to 0. What it means is we're setting all the ports on the A, we're setting the whole port to being an output. If we had said trace A is equal to 1, that would have set this pin to being an in. So we're setting it to in. So we're saying trace A is equal to 0, then port A is equal to 0, which is initializing the port and making it 0 volts at first. What port A does is selects port A, then sets everything to 0 volts. The potential is set to 0 volts. If we had said put A is equal to 1, that would set it to 5, because this is digital in, out. 1 represents 5, 0 represents 0, 4. Okay, so port A is equal to 0. So what are we going to do next? We're going to create a loop, an infinite loop, where the pin alternates between two states being on. So we're going to say port A auto equals to 0B 1 2 3 4 5 6. Okay, so what am I doing here? This is in the port A, there are six pins basically, and each pin is represented by a pin. So we've created a binary number here. That's what 0B is representing, binary number with 6 bits. So this one would be the smallest pin would be the least significant bit, and the biggest pin would be the most significant. So this is the one that is on 7 here. That's this 0, and this one, the one that is on 2. So we're setting the one that is on 2 to 1. That's basically what we're doing here. We're setting this one on. In pin 2, we're setting it on. And what we're doing is we're using this OR operator to not affect any of the other. So if any of the other pins have a certain value, it's not going to be changed because these guys are zeros over here. So these zeros, you OR them with any value, it will get that value that you put in. So if we say 1 or 0, you get 1. So it will not affect any of the. So next to this, we're going to say delay ms 100. So we're going to make the system wait for a short time, then before going to the next piece of code. So what we're going to do on the next piece of code is we're going to say put a and equals to 0b 111 So we've done basically the opposite of what we did here. What we're saying is this one, we're going to end this to the already existing state of the port. So the last one, you end it with 0. Doesn't matter what the value it is, it's going to be 0. And the other ones, if you end it at 1, if they are already ones, they will remain 1. If they were zeros, they will remain zeros. Okay, that's what this AND is doing. So we're ending everything on a bitwise scale. So anything ended with 0 is 0. Anything ended with 1 is whatever you. Okay, so we're trying to affect one port without affecting the other. And we're going to wait another short time. Then the code is going to. So it waited another 100 milliseconds. Then the code is going to. So it's going to go through this code in an infinite loop forever, basically. So we're going to say. Okay, so in mikroC, what we're going to in Proteus, is we're going to go on edit properties on the microcontroller. We're going to select the hex file that has been made by mikroC. The hex file is going to be in the directory where your project is, and it's going to have the same name, and it's going to have the the it's going to have the suffix .hex. I'm going to select this, press. So if we run this code, just as expected, the LED goes on and off repeatedly forever. So it goes on, waits a while, goes off, waits a while, goes on, waits a while, but doesn't affect the states of these pins at the bottom. Pins will remain as 0 time. See the blue light, blue color here shows that they are off. Of the alternating red and green, and red and blue shows that it's turning on and off periodically. These ones are not being affected. Okay. So that's all for this tutorial. Thank you for watching.